guys, welcome back. In this video I'm going to talk about irrational numbers and surds. First, let's review some facts about fractions and decimals. We know that some fractions can be written as decimals that terminate. For example, 1 over 4 equals to 0.25 and 3 over 4 equals to 0.75. And there's also some fractions that have decimal that do not terminate. For example, 1 over 3 equals to 0.333. Ellipsis, which we write as 0.3 dots, and we call this 0.3 repeating. And some fractions have decimal representations with more than one repeating digit. For example, 1 over 11 equals to 0.09090909 repeating, which we write as 0.0909 repeating. And it is easy to write terminating decimals as fractions by using a denominator which is a power of 10. For example, 0.14 equals to 14 over 11, which equals to 7 over 50. However, decimals that have a repeated sequence of digits can also be written as fractions. For example, 0.123 repeating can be written as 41 over 333. And let me show you how to do this. Let's, for example, write 0.2 repeating as a fraction. Firstly, we can let s equals to 0.2. Hence, s equals to 0.2222 ellipsis. Then 10s equals to 2.2222 ellipsis, because we multiply this by 10. So a equals to 2 plus 0.2222 ellipsis. Therefore, 10s equals to s plus 2. Hence, 9s equals to 2. And therefore s equals to 2 over 9, and 0.2 squared, 0.2 repeating equals to 2 over 9. Okay, now for the final part of revision, let's recall the concepts of rational numbers. A rational number is a number that can be written as a fraction p over q, where p and q are integers and q does not equal to 0. All integers are rational numbers. For example, 3 equals to 3 over 1. Okay, now let me show you something that you haven't learned before. Let's talk about irrational numbers. Mathematicians up to about 600 BCE thought that all numbers are rational. However, when we apply Pythagoras' theorem, we encounter numbers such as square root 2 that are not rational. The number square root 2 is an example of an irrational number. An irrational number is a number that is not rational. So an irrational number cannot be written in the form of p over q. Besides that, it cannot be written as a terminating or repeating decimal. Therefore, we can imply that A irrational number is a number that goes forever but does not repeat. Other examples of irrational numbers include square root 3, square root 14, and pi. And of course, there's plenty of irrational numbers, and these are just the examples. Okay, now let's talk about surds. In year 8, we looked at squares, square roots, cubes, and cube roots. For example, 5 squared equals to 25, and square root 25 equals to 5. 5 cubed equals to 125, and cube root 125 equals to 5. In general, we can take the nth root of any positive number a, and the statement nth root of a equals to b is equivalent of the statement b n squared equals to a. We conclude that an irrational number which can be expressed as the nth root of a, where a is a positive whole number, is called a surd. And for example, square root 2, square root 7, and cube root 5 are all examples of surds. However, square root 4 and square root 9 are not surds since they are whole numbers, because they can be expressed as 2 and 3, which are whole numbers. And the number pi, although it's irrational, it is not a surd, because it cannot be expressed as nth root of a. Okay, that's all for today. I hope you all understand. Please subscribe and I'll see you next time.